Hi friends, welcome to another video on my YouTube channel, and in this video we will cover how to call an LLM and how to set up different parameters to get different types of responses. So as you remember, in my last video I have explained how an LLM behaves internally when you change different types of parameters to it. For example, temperature, top P, top K, in what scenario LLM behaves in what manner we have explained theoretically in the previous video, right? This is a demo on that. In this video, we will see how to call an LLM API and how to tweak different parameters to get a different type of output. So basically, first you will need this code I have written in Python, and I'm running it in Jupyter Notebook to explain it cell by cell. For you to run it, you have to set up a virtual environment. I'll create a separate video if you want me to create a virtual environment, how to create a virtual environment for Python, but it's fairly easy. You can just look up into the internet and it will just tell you the steps. They are simple steps you just need to follow. So after you have set up a virtual environment, you can just set up your environment in this IP Jupyter cell, like here. Like here you can search for an environment. My environment name is VENV. I can just select it, and then you can run your Jupyter notebook in VS Code. So to call an LLM, first you will need the API key. So I have an open router API key. You can use any API key, but for that you have to change your LLM again. For example, I have open router API key, so I'm using OpenAI LLM. I'm importing OpenAI from OpenAI, and I'm using this to call the LLM. So if you have Gemini key, then you have to use a different library that is supported by Gemini and call the LLM using that. So depending on your API key, only this part will change. So this syntax, the part which you are using to create a object to call the LLM, only this part will change based on your API key. Please note, I have an open router API key. That is why I am providing a base URL and an API key like this in the OpenAI object. But if you have an OpenAI API key, so if you have OpenAI API key, the API key provided by the OpenAI itself, then you don't need to provide these two. So by default, this class by default searches for an OpenAI API key, and if you don't have that, then you can just provide another API key like this. Similarly, this base URL is only needed when you are using Open Router. If you are using OpenAI directly, then you don't need to provide this base URL. So right now, this will go to Open Router. It will pick up a LLM model from that, and it will just use this API key to call that LLM model. So right now I have set up my API key in the env file. So you see this .env file, right? I've just kept a key value pair, something like this. So here you can set up your own API key, whether it's an Open Router API key, Gemini API key, or OpenAI API key, or any other API key which you are using to call that particular model. So you can just put that key value pair in this .env file, and these two functions, they will find the .env file in your project, and then it will load that .env file to use those environment variables in your code. So after I have set up the Open Router API key, I can just choose this getEnv method to get that API key value and load it here. So I have already run these cells because these cells might take time, might take a minute to run after when the actual calls happen. So I have already kept them running. I'll just go through the code line by line and explain you the things. So the next cell is generate response. In this, I'm calling my LLM model. I'm actually calling my LLM model using these methods. So I'm not using any framework here like LangChain or LangGraph. Otherwise, you don't need to do anything like this. If you've worked on LangChain, LangGraph, like that provides fairly simple methods to call an LLM model. You just have to invoke the model, right? Here, as I'm not using any frameworks right now, I'm using this method to call my LLM model. So here is my client. I'm creating my client here. Now I'm using client to start a chat. So it said client.chat.completions.create. It will create a new chat with the LLM model. Here you can provide different params that you want to tweak. For example, I have provided by model. So I'm using GPT-4o mini model because the cost for this model is like fairly less than as compared to other models for demo purposes. You can use any model you want. You can just provide the name here and it will just start using that model. So, and then I am providing my prompt. So in my prompt, I'm saying the role is user and my prompt is this. So prompt and everything, I'm just getting it in params of this function, and whatever prompt I'm providing in this function, I'm passing it to the LLM model along with the role as a user. Then I'm tweaking different parameters like temperature, top p, max token, stop sequences, as we have seen in my last theoretical video. We'll just see demo on these in this video. So after you get the response from an LLM model, you get the response as a huge object. So instead of just getting the text as you've generally seen in the UI in ChatGPT UI and all those things, you generally get a huge object. So if you want to see that object, let's do that. Okay, let me change something here. I'll just say response. Just say response here, and I'll just let me create another cell here and copy paste this whole cell on the top cell. So let's do that. Let me remove all these for demo purpose. Let's try it with one, and generate token, generate response. Let's not print the output here. Let's return the response itself. Let's remove this part, and instead of returning a text, let's return the whole response here. Let me comment out this, and after we get the response here, I'm just printing that. Okay, let's run it. It will take some time, so as I'm using a really small model, it might take some time to provide a response for this simple prompt. So here what I am doing, I have just provided a prompt. A prompt is a simple prompt like writing a short story about a robot learning emotions. So I'm just trying to create a story using LLM. These are the parameters I have tweaked, so I've just kept the default ones here. So temperature is 0 0, and top p is 1, like top p is like including all the tokens. If you remember from my theoretical video, top p1 means like getting all the tokens that has been selected by LLM model to generate the response, like it's the default value. Then temperature is 0, I've just kept it 0, and then I'm printing everything, the parameters as well as the output. So if you will see here, oh, I've not run this again, right? That is why. Let's run it again, and let's try it one more time. Let's wait for a few seconds again. Okay, yeah, now you can see, right? Now this has we have got an object here. So instead of simple text, we have got a object which has lots of things in it apart from the answer from the LLM model. So here we have ID, maybe a unique ID generated by the LLM for responses. Then we have choices. Then we have other data. Then in the messages you have your actual answer. So if you will see, you have an object in which you have ID and other things. Inside this object you have your choices. Then inside the choice you have message, and in message, in the content, you have your actual answer that is provided by the LLM model. So this content contains the whole story. So if I like scroll to the right to the end, somewhere it will end, then you will see other properties, other metadata as well, that is provided by the LLM along with the answer. So if I like keep scrolling to the right, okay, so now this is the metadata that LLM model provides along with the answer. So to ignore all this, like to show you just the answer that is written by the LLM model, instead of showing this whole thing, I'm doing this. So whatever choices LLM model is providing, I'm just going to the first one, and from the message I'm just printing the content here. So let's do it again. I'm printing the content here. So as you can see here, you can have different choices here. So in case LLM model returns different answers. So sometimes in ChatGPT, I'm not sure if you have seen, so sometimes whenever you pass a prompt to ChatGPT, it provides you two different options or two different types of response, and it asks you to prefer one of them, like to get the data, basically to get the input from you, what type of format you would prefer. So those kinds of things happen here as well, like it can provide you multiple responses as well for a different for a single prompt. So maybe in the prompt something is there, like give me 2-3 stories, or I don't know, maybe something in prompt will lead it to provide multiple responses instead of one. In that case, you will have multiple choices here, and each choice will have a message, and the message will contain the actual text generated by the LLM model. So as you can see right now, I have only one choice in the choices list. This is a list. In this I have only one choice, and inside it I have a message which contains the actual text generated by the LLM. You may have different multiple choices here as well. So let's look into different configs that I have already kept running. So here I'm tweaking the parameters for different scenarios. So first, deterministic short. Deterministic means I'm just keeping the model as less creative as it can be while generating a story. So I have set up the temperature to 0, but I have kept the top B as default to 1. Now I want my model to be creative, so I have set the temperature to 1. So this is the maximum allowable value for an LLM model to be set. You can go up to 2, but 1 is like more than enough. Then I am restricting top P, so I'm just saying 0 because now it will just pick up the first token, like whatever the first token is there in the selected tokens, then it will just pick up the first one. It will not look into the others. Then there is stop sequence demo. Here you can set up the stop sequence like this. So all these params I'm just passing to this method here on the top. So as you can see, I'm just setting all of them here by passing it in the param, like temperature, top P, max tokens, stop sequences. All of them are coming from this config list. So in the first demo, I've just set up the stop sequence as /n. So model will stop generating as soon as the /n token is generated by the model. Or you can pass multiple stop sequences. Except for example, I have put the this dot as a stop sequence and the word end as a stop sequence. So if either of them occurs while generating the output, model will stop generating output there, and it will just return you the response until that point. Then there is max tokens demo. So as you can see in these configs, there was no max tokens set. So now I am just setting up the max token as 10. Please remember here, this is the number of token, not the number of words. So it could happen that if you have set up like 20 tokens, you may not get 20 words because a word may contain different multiple tokens. Now let's see the output of all these configs. So what I am doing for the list of this config, I'm just using a for loop, and for each config I'm just printing what values I've been setting up, and then I'm just passing this to this function I have written above to call the actual LLM, which is here. So I'm passing the prompt, temperature, top P and everything from the config here, and after that I'm just printing the response, the actual text that is written by the model instead of this object in the output. So let's see how it is behaving with different configs. So the first response is from deterministic short input, where the temperature is 0 and top P is like default. So max token value here is coming from here, because if the max token is not from the config, I'm just setting up a big value for max tokens. So this much token is enough to writing a small story. So I just kept a random value here. Now stop sequence is 0. So as you can see, this story is generated by LLM model. So you can just try it on your own and you can just go through the whole story, but I just wanted to show you observe a little bit of difference. So here this is the output with a temperature 0, and the next output is for the same prompt with temperature 1. I mean I want model to be creative here. So if you will just compare the first sentence, like in a not so distant future in a bustling city filled with towering skyscrapers and neon lights, if you will compare it, so this looks like a creative story, right? Like here it directly started on the point, but here it looks like a normal fairy tale, like once upon a time in a non so distant future, a company called Agnes Crop created a groundbreaking AI known as EVF. Like you can see a little bit of difference, right? While writing the stories, this looks like a fact or like a summary or like a deterministic story, right? No, less creativity. I'm not saying no creativity. Obviously, this is a story, so creativity is there, but less creativity as compared to this response. Like if you will go through the whole story, you will observe that this looks like here model tried to be more creative, like picking some more random words that fits to be a story. So you will so that's why in my theoretical video I just said, if you are generating a code or you are summarizing a document, like things like that, you should keep the temperature low, and in case of creative work like writing stories, blog, you can set the temperature to a high value. It will give you a better output for them. So like for example, this looks like a more like a story, right? Once upon a time and all those things, but you will miss that thing here. Now next, let's look into the next output, which is top P restricted. Here top P have set up to 0. So here the top P was 1, right? 1, but here I've restricted top P to 0, and temperature is fairly high, not like very high, but fairly high. So as you can see, again it's stopped choosing few words that you might have seen here, like once upon a time and all those things. So as top P is set to 0, it's just picking up the first token that is being selected by the model, like maybe the highest probability. If you sort by the probability, maybe the highest probability. So there is no chance the tokens that are generated after the first token with the highest probability, they will come in the response. It's just picking up the first one. So as you can see, it affected the response. It could be because of the temperature as well, but top P behaves in a manner, in the same manner. It will just pick up the first token, as the first token will have some probability, right, and it will just reach the limit. So it will be difficult to observe the difference between these two responses. Like maybe you can try with temperature 1 and top P 0. You can maybe see how the responses differ. But with human eye, it will be difficult to observe this for every prompt. Maybe, for example, if you are writing a code or summarizing a document, maybe tweaking these parameters won't matter much. Like it will give you similar responses every time. So that's why I've chosen the prompt to create a story. It's much better for the demo purpose. So you can just try it on your own, like maybe set the temperature to 1 and top P to 0, and play accordingly. Like you may see the differences in how the responses are being generated by the model. Now here is the stop sequence demo. Like this is very easy thing to demo, because here I have set up the stop sequences to I've just put the wrong output. Let me check. Here in the first one, I have just put the stop sequence to /n, and the next one is dot and end. So as you can see in the response here, let me go back. Top P restricted here. In this, the first one is stop sequences /n, right? So as you can see, as soon as the line is completed, it's stop generating the output. So here, if you will see, this is a single line. It's going on. And as soon as the line is complete, I mean the paragraph is complete. So if you will observe, here /n is being generated by the model after each paragraph. So this is a paragraph, right? So here this is one sentence, then another sentence started, and then this is going on, and it completed. Now it's an end of the paragraph. So after end of a paragraph, model is generating a /n. So here, as soon as the first paragraph got completed, you can see it's not generating other lines. Like the story is incomplete obviously, but it will stop generating the output as soon as any of the stop sequences occur. So this is how stop sequences behave. As you can see, if you remember in the in the next config, I have set up the stop sequences as full stop and end, right? So if you will see in the output of this, here instead of just waiting for the paragraph to finish, it just stopped generating the output as soon as this dot I think dot appears in the output. So I think this is the end of the line, end of the sentence, not a paragraph, and that is why it stopped generating the output as soon as the dot appeared. Or maybe the word end came here, I don't know. But yeah, this is how stop sequences behave. If any of them, any of the token that matches them comes into the picture, model stops generating the output. Then there is max tokens demo. Here I have set up the max token as 10, and as you can see, it just gave you the 10 tokens. So it might be 1 2 3 4 5 6 7 8 9. So as you can see, these are 9 words, right? Not 9 words, but as you have seen, max token is 10. There are 10 tokens there. So maybe this comma is a separate token and on is a separate token, I don't know, or maybe word has 2 different tokens in it. But because of this, now we have just this small line. We don't have a full sentence as well. So this is how max tokens work. It will just give you that much amount of tokens in the output, no matter if it is complete or not. So this can be used to reduce the cost and all those things. Maybe you can just say to summarize something in this much amount of words, and you can set up the token limit, like don't go beyond that. So it can reduce your cost, because cost is like directly affected by the number of tokens being sent or being generated by the model. So this is how tweaking different parameters work. So please note, I'm not setting up top K here. So there are some models that will allow you to set up top K, some will not, but I couldn't set up top K here. Maybe you can find a model and try using top K and see the output for that as well. But top K, as I explained in the theory, will behave in the similar manner. So let's move to two other params that this model supports, is like frequency penalty and presence penalty. So these two I have not covered in my theoretical video, so I will explain them a little. Frequency penalty and presence penalty like penalize the occurrence of a word. So for example, let's first see the demo, like then you will understand. So similar thing, I'm just setting up the config for different frequency penalty and presence penalty. So in the first one there is no penalty, default 0. Then I'm setting up the frequency penalty to 2. In the next one I'm setting up the presence penalty to 1.5, and then presence and frequency penalty both are to a high number. So please ignore this, I'll just explain this later. And this is the same similar method as you have seen above, like I'm just calling the client with different parameters I've been providing in the input of this method. So this method is being called here, generate response, and then I'm just whatever response is generated by the model, I'm just counting the number of words, how many number of times a word is occurring in that response here. So what I'm doing, using this config, I'm just looping over this config, I'm just calling the model to generate the response, and after the response is generated, I'm just counting, I'm just using a counter to count the number of how many times a word is appearing in the response, and I'm just printing that to show you the demo. So this code is about that, where I'm just getting the text and using this regular expression and everything, and using this counter from the collections of Python, I'm just counting how many times a word is appearing and just putting it in the map and returning the map, and just printing it here. So as you can see in the frequency penalty 0 and presence penalty 0, what it does, like it behaves normally, like the way it should behave, like no restricted behavior. So this is the, my prompt is I think something about exercise. So explain the importance of exercise in daily life. So it's giving you different points, like all the points like sleep quality, physical health, mental, everything, right? And now if you will see the repeated words, exercise have come 9 times, A has come 9 times, N has come 4 times, and so on. Like I cannot go through every word, but yeah. Now just focus on the exercise word. It has come 9 times in the default behavior. Now I have put a high frequency penalty in this next response. So as you can see, the number of words 9 times exercise is coming is less. So what presence penalty, frequency penalty does, it penalizes the generation of that particular token the more number of times the token is generated. So for example, let's say exercise is a token, and the more number of times the exercise will come into the output, the less likely it will come in the output again. So for example, here a model penalizes the generation of a token based on number of times the token has already occurred in the response. So it will just avoid printing the same word again and again in the response. So this is how you can use it. So maybe you want your model to be creative and you don't want a single word model to keep repeating a word in the response. You can use these two restrictions set up in the model, and it will just behave like that. So as you can see, this time the exercise is like not very less, but as compared to the previous one, the count of exercise and A is like less as compared to the previous one. So exercise was here 9 times, A was here 9 times, and here exercise and A are like purely less as compared to the previous one, right? So the more number of times a token will appear in the output, the less likely it is going to happen again. Then there is high presence penalty, which is similar, but internally it behaves a little bit different. So here again, as you can see from the first answer, the number of times the exercise and A are occurring, it's fairly less as compared to the previous one, right? So here model penalizes a generation of token not based on how many times a token is appearing, but based on whether the token is present in the output or not. Bit difference actually. So here the more number of times the token appears in the output, more penalty will it suffer. But in this case, even if the token appears in the output once, it will suffer from a penalty from the model. So this is like presence penalty. If the token is present, then it will most likely suffer from a penalty. In the frequency, the more frequently the token is coming in the output, the more penalty it will suffer. So that is how frequency penalty and the present penalty works in the LLM model context. So just the last thing, we have kept frequency penalty and the presence penalty like fairly high, and if you can see the exercise is like even more down in the count, right? So here it was 7, 7, 10. Now exercise is just 5 times occurring in the response, A3, in 3, and all those things, right? So this is how these two params behave in terms of model output. You can just play with them, right? Like create get an API key. If not possible, like just go to OpenAI and maybe get an API key of $2-3. So $2-3 are enough to play around this, right? Like they just don't use it to generate the code. Just use it to call the model for simple prompts and get the output. It works perfectly fine, like for a long time. And use smaller models so that your cost is minimal as possible. So generate a API key like for $2-3, and you can just uh, play with it and see how the model is behaving with different params. It will be a good learning for you. So that's all for this video. So in next videos I'll be maybe start with the LangChain LangGraph, and like we will see few videos on LangChain, how the LangChain behaves, how we can use LangChain to call LLM model, what are different what it provides you, and how to behave, create small agents on this. And this all will be coming in my future videos. So please wait for them and watch them when they come. Thank you. Please have a good day and bye.